Unit 1, Topic 10, Trees. Tree is a finite set of one or more nodes such that there is a specially designated node called the root. Now, tree is a finite set of one or more nodes. The structure of the tree will always start from the top. The top, wherever the node is existed, that is called as some root node. Now, this is what the root node is so called. So always tree starts from the top position. The top element is called as root element. And it may have one or it may have more nodes as far as the definition of tree is concerned. When it is having more nodes, then we'll start structuring the tree from top to bottom. So the way how we'll see tree outside, the same way this also the tree where every node is extracted from the root node. So we used to call these are what? Children nodes. And this is what? Parent node. And these nodes are called as children nodes. And the remaining nodes are partitioned into n greater or equal to 0 disjoint sets from T1 to Tn. Which of these sets is a tree? And now look at this 10. 10 is one of the element, and assume the other element is also existed in the tree. Okay, now that is of 13 for our assumption I am taking. So all these nodes are partitioned into disjoint sets. Which of these sets are called as a tree? So this is called as a subtree, and this is also called as a subtree. So again I am pronouncing it is a tree where it have a ability to have one more branches from this 10. There are different terminologies what we have to focus about the tree. Now, the first terminology is what? Root. Root is what? The node which is specially designated. What is root node? As far as the example is concerned, we were taken this example, right? Just before. Now, 12 is the starting node and this is called as root node. This is called as root node. So assume that my n value is some 6. Now n is greater 0. Fine. Now the 6 elements are what? 12 comma 10 comma 8 comma 7 comma 30 comma 15. These are what? My n elements. So as far as definition of a tree is concerned, all these nodes are what? Disjoint sets. Correct? Now, how to construct the tree from these nodes are, the first element I am taking as what? Tree. So that is of 12 is my first element and this is called as root element. Now, the second element I am taking as 10 and this is what? Children. This is what? Children. Now 12 is root and also called as parent node. Now 12 is having the other node which is 15. Assume this is what? 8, 9 or something 10. Now look at this. So 12 is a node as it is a starting node. As it is a top of the tree, we are calling this with the name of root. The other nodes came from the top which is root. These nodes are called as children nodes. Now 10 can also have the other node if n value goes beyond of 6. If n value is 7 or n value is 8, So you can take the elements from 10 also. Then this 10 is called as what? Parent node. And this is called as what? Children node. Finally, this partition is called as subtree. Now, so what do you mean by leaf and terminal? Leaf or terminal, both are giving the same mean, that are the node which doesn't have any children. Now look at this. Assume that 10 is having one children, which is 17. Now 10 is having a children 17. So 10 is doesn't called with the name of leaf. What is leaf? Leaf node is the node which will not have any children. Now we did not find 15 children, 8, 9, 10 children. There is no children for these nodes. Hence 15, 8, 9, 10 are called as leaf nodes. And these also can be called with the name terminal. Now what about this 12 and 10? These two nodes are called as non-terminals. And even the 17 is also called as leaf node. So find out leaf nodes from this tree: 17, 15, 8, 9, 10. These nodes called as leaf nodes. What do you mean by leaf node? That it is not having any children. Non-terminal is what? The nodes which are having children. Now, what do you mean by degree? Degree is what? The nodes which are extracted from this. So 12 degrees what? 1, 2, 3, 4, 5. Depth is what? We started from this node to the bottom, right? The depth of this. How many nodes it is having, the levels, that is what depth. We'll see the example to understand in brief and better way. So assume that there is a tree. This is what the tree. So for the convenience, I wrote all these notes with the alphabets for the convenience. There are many terms that are often used when referring to trees, as far as we were discussed in the previous slide. And this tree has how many nodes? 13 nodes. The root contains A. This is what root node. It contains A. And we normally draw trees with their roots at the top. The number of subtrees of a node is called as its degree. So A degree is what? A degree is what? 3. A to B, A to C, A to D. Now what do you mean by degree? The number of subtrees of that node is called as degree. Now what is the C degree? C degree is what? 1, because it is having one subtree. Now B is having how many subtrees? 1 and 2. So B degree is what? 2. E is having how many subtrees? K and L. So the degree of E is 2. Now F is having 0. No subtree we found. Now there are leaf nodes, what we were come across in the previous slide. Leaf nodes are what? K, L, F, G, M, I, J. Correct? And non-leaf nodes or else non-terminals. These K, L, F, G, M, I, J are called as terminals. And the other remaining nodes are called as non-terminals. Right? Now, the roots of the subtree of a node X are the children of X. Now, look at this K. K doesn't have any children, but E have a children, right? Now, E children are K and L. Now, the parent node of K is what? E. Parent node of L is what? E. When the parent is same for two different nodes, then these two different nodes are called as siblings. So K comma L are siblings. Now, you can also find ancestors of this K. K ancestors of what? E, B, A. So this is what the major terminologies what we will see, and we will also having the other term which is depth and level. Level is what? Something we will be starting at the top, right? See, this is what root node, and we started at this node. Now it starts with level of 1. Now the generations of this A, or the next level of A, that is what the child node of B always will be at n next node, that is of 2, correct? Now let us assume A level is at P. A node level is P, then the children of A node will be P plus 1. So that is what? P is equal to 1, then it becomes the children node of B becomes P plus 1. Hence level 1, level 2 and level 3 and level 4. Okay. Now the height or depth of a tree is defined to be the maximum level of any node in the tree. The height and depth of the subtree is maximum level of any node in the tree. So finally the depth of this tree is what? 4. And you can also see some kind of trees. We'll see some kind of trees. So we'll draw here. You can see a tree which will have the nodes only at left side. This is also tree because only one node is existed in the top, which is called as root node, and the A node is having children nodes. So the way how we were found in the previous diagrams, the same way you can find here. Hence it is called as a tree. But what kind of tree it is? It is left skew tree, because the arranging of all the nodes were at only left side. So probably you can guess what is right skew tree. That is what arranging the elements all at right hand side, no element is at left hand side. Then it will be called as right skew tree. And you can also see some other trees which are A, B, C and D something E. Now see here. Prior to this diagram, in our explanation, we were taken 13 nodes diagram, no? There we found A node with 3 children. So this is what a general tree, and the difference of this tree and this tree is what? This is what binary tree. It is what normal tree, and this is what binary tree. So the difference is what? A binary tree is a tree which will be having non-empty nodes. That is, empty nodes also can be existed. That is, A is a node where it is having 1 children. Now it is called as binary tree. A is having 2 children. It is also called as binary tree. When it is having the other node, it is not called as binary tree. As far as binary tree definition concerned, a binary tree can be existed with 0, 1, 2 children. That is, at most 2 children are possible in binary tree. So you cannot place the children nodes, beyond of this 2. So when you are going for this third node, it is going beyond of 2. So it is not existed when you wanted to call this as a binary tree. So 0, 1, 2 are what? At most. And there are even the conditions that you can see in the dictionary's concept. So how to arrange the elements in binary tree? What is the condition? That you can go through that video to find out how to organize or how to construct a binary tree. And there are even the other trees, so where you can place the elements in such an order. So we will place all these elements in this particular manner to do operations, insertions, deletions, and to perform these operations, we'll place the elements into this particular order. So this is about trees. Thank you all.